Okay guys, I hope you can see this. I'm now going to go over the solutions to the speed, distance, area questions which I gave you a few days ago. I've already given you the marking scheme, but this is me going through the work solutions for you, okay? So first question, Damien is putting a mirror on a wall. Okay, the wall is 330 centimeters wide. Okay, and the mirror is 100 centimeters wide. And we want to work out the value of L, this distance here. In other words, how much of a gap does it need to have to the left or right of the mirror to get its square center in the wall? Well, this one's fairly easy, folks. First of all, we need to figure out how much space have we got here. So 330 minus 100, 230. Well, now we just need to make sure that this is all exactly the same. Divide by 2, 165 centimeters. And there you go. Question 1. Question 2. The diagram below shows a shape G on a grid. The point P and S are also marked. Each square, blah, blah, blah. So our shape looks like this. Obviously I don't have a grid, but you at least know what the shape is, and there is this many boxes. Okay? Each of these squares is a length of 1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 centimeters is the perimeter, which is what they're asking us here. Next thing they ask you to do is draw an image of the shape G under a translation that sends the point P to S. In order to do that, I need to first of all clear my board. So, our shape G looks like this, and the point P is here. Next we have the point S, which is here. If they want a translation so that the point P is now sitting on the point S, your image or copy is simply going to look like that. That's it. Question 3. The following, it's question 3 also labelled question 5 on the worksheet, okay? So, question 3/5. The following is a part of a bus timetable from Galway to Limerick. James lives in Oranmore and he needs to be in Limerick by 9:30. What is the latest time James can get the bus from Oranmore? Well, all you do here is look at your timetable, folks. That's it. He needs to be in Limerick by no later than 9:30. Well, the first train is in Limerick at 8:45 and would leave Oranmore at 6:48. The second train arrives in Limerick at 9:25 and leaves at 7:28. So either of those is good. The third train arrives in Limerick at 9:44. So that one's no good. So the latest time that he can get the bus from Oranmore is 7:28. How long does your journey take? Well, 9:25 minus 7:28. Now we don't just do straight subtraction, guys. There's 60 seconds in a minute, 60 minutes in an hour, so it's not 9.25. Okay? What I would be doing is I'd be probably changing this whole thing to minutes. So 60 times 9. 540 plus 25, 565 minutes, okay? And then you've got 60 by 7. Actually, you know, that's overcomplicating things. Look, it's really simple, guys, okay? Just count it up in your fingers, alright? If he starts at 7:28, okay? How long does it take him to get to 8 o'clock? 32 minutes. Okay? How long does it take to get from 8 o'clock to 9:25? 1 hour 25. Plus 32, 1 hour 57 minutes is how long the journey takes. And that's actually the simplest way to do it. Break it up, folks, okay? This is just basic adding. What makes it tricky is it's not a decimal point. You can't just do a normal subtraction. You've got to remember that we're adding up in groups of 60. Okay, next one. It takes Gina 1 hour and 15 minutes to drive from Oranmore to Limerick. So the previous times are all for buses. This is saying driving, okay? So, what fraction of an hour is 15 minutes? Well, that's a quarter, guys. Okay? 15 minutes past a quarter past, okay? 15 goes in the 64 times. The distance from Oranmore to Limerick is 90 kilometres. Work out our average speed. Whenever you see a question that's asking you to calculate speed, distance, or time, you draw this triangle. Every time. Seriously, the amount of times you aren't bothering to do this, even though I say to do this, is just getting ridiculous now. Every time you see a question asking about speed, average speed, distance, or time, you draw that triangle. They want to know what our speed is. That means we cover S, distance over time. We're told in the question her distance is 90 kilometres. And it takes her an hour and 15 minutes, which as a decimal is not 1.15 because 15 in 60 is a quarter. A quarter as a decimal, 1.25. Divide 90 by 1.25, 72. 72. What kilometers per hour? You leave this out, you get docked marks. You are guaranteed you'll be docked marks if you leave that out. So don't leave it out, okay? Now, Ned and Laurie had a race. Laurie was given a head start, so she ran a shorter distance than Ned. And by the way, folks, when you're looking at these videos, you need to have the questions out in front of you as well. I have no way to project these questions onto my whiteboard hanging off my kitchen wall. So you need to be following the question on your phone or whatever, on your tablet, laptop, whatever you're using, so you can understand what I'm referring to in these questions, okay? It's up to you to be doing this. Now, Ned and Laurie had a race. Laurie was given a head start, so she ran a shorter distance than Ned. The graph below shows the distance along the track in meters that each of them was from the starting line after T seconds of the race. What distance did Ned run in the race? Well, he started at 0 and he finished at 30, so 30 meters. What distance did Laurie run during the race? Her curved line starts at 5 and finishes at 30. So she ran 25 meters. How many seconds did Laurie take to finish the race? You go up to the top of Laurie's curve, where it hits the dotted line, and go straight down and you get to 10. So it took her 10 seconds. Okay? And how long did it take Ned? They don't actually ask this question, I think, but if they did, it's going to be, you go up to him, go down, and he's between 10 and 12, so 11 seconds. Work out Laurie's mean speed during the race in meters per second. Well, speed. As I said, if you see a question of speed, distance, time, you draw a triangle. They want her speed. She travelled 25 meters in 10 seconds, 2.5 what? This is meters, folks, that's seconds, so this is meters per second. In the previous question, it was kilometres and hours, so it was kilometres per hour. Alright, next bit. Ned said, if I ran at the same speed for the whole race. Is Ned correct? Give a reason for your answer. Ned is not correct. Now, if you say no, or Ned is not correct, you're getting at most half the marks. It says justify. Give a reason for your answer. Why is he not correct? Because the graph looks something like this. Okay? This is Ned. If he was running the same speed the whole time, his line would look like that. It's not. It's a curve. He started off slow and then sped up, which is how all humans run. Whenever you look at anybody running, or if ever you have taken the time to run. When you first start running, it takes you a couple of seconds to get to your top speed, and then you speed up. And that's exactly what we see in this graph. So no, he was not running the same speed every time. He sped up. How do we know? The line's not straight. A helicopter leaves Shannon at 9:30 and arrives in Limerick at 9:45. It travels 25 kilometers per hour. Find its mean speed. Speed, distance over time. And they want this in kilometers per hour, folks. So, 25 kilometers. It left at 9:30. It arrived at 9:45, so its journey took 15 minutes, which is 1/4 of an hour, which is 0.25. Okay, so it was traveling at, I'm pretty sure this is, 100 kilometers per hour. Okay, 100 kilometers per hour. Next, Gráinne is taking part in a training session. The graph shows the distance she travels during the session. 4 parts of the graph labelled A, B, C and D. And her graph looks like this. Alright. For which bit was Gráinne running for 20 minutes? That would be this one here. Okay? You can't, I haven't put it up, so actually that would be 5, 10, 15, 35. Okay, so that 20 minutes. C. Okay? Gráinne stops for 15 minutes. That would be up here. D. Gráinne walks for 10 minutes. That will be this one. How do I know it's this one? Because A, it's a time of 10, and B, it's not a steep an angle. This is a really steep angle, meaning she was going fast. This is a shallower angle, meaning she was going slowly, and she stopped for 5 minutes. B. Gráinne runs 4 kilometers in 20 minutes at a steady pace. Find her speed in kilometers per hour. Draw your triangle. Speed, distance divided by time. 4 divided by 20. Now, you'll see what I'm going to do now here in a sec. 4 divided by 20 is equal to 0.2. Well, 0.2 what? Kilometers per. This is in minutes, folks. So we've now found her speed in kilometers per minute. How would I get to kilometers per hour? Times this by 60. Why 60? There are 60 minutes in an hour. 12 kilometers per hour is her speed. Students in a PE class are doing a fitness test. Each student runs from a baseline of a gym to halfway line and back again. Okay, and this is called a lap. So our graph looks like this. Okay, that there is going to be your halfway line. Okay, this is distance from the start. Okay, so they travel this far. The reason this is going down is they're now going back to the start. Okay, folks, so that's 5, 10, 15. Okay? How long did it take Miriam to complete her first lap? Actually, 15 is here. It took her 14 seconds from the graph. From the graph, how far is the baseline? The baseline is half, so it's 7. How far? Sorry, no, I'm talking about how long. The baseline goes up to here is 30 meters. Okay? Now, in her second lap, she increased her average speed to 5 meters per second. On the diagram, continue the graph to show her distance from the baseline over the course of this lap. Okay, so let me think. Okay, so if she travels 5 meters per second, okay, and then previously she did 30 meters in 7 seconds, so that would have been 4 and 2/7 meters per second. Okay, Now she's traveling 5 meters per second, so she's getting that bit faster. So what that would mean is she would get to here, if she started at 14, she'd be at 20. This is what your graph would look like, folks, okay? And then she would come down here at 26. How am I getting that? Because if she's traveling 5 meters per second, it's going to take her 30 divided by 5, 6 seconds to get to here. So my graph, the distance from here to here on the x-axis of my graph should be 6. And then 6 again going back. Because we're being told it's the same speed. Okay? Tina is standing beside a racetrack. This is one of those red card, blue card questions. So, we have time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Red, blue. Okay, so at a particular time the red car had gone 70 meters beyond Tina and is traveling at a speed of 20 meters per second. So it's gone up in 20s. Okay? And the blue car was 20 meters past her, but was going at 30 meters per second. So it's gone up in 30s. That's a 7. Alright, now, at how many seconds will they both be the same distance from Tina? Here, at 5 seconds they're both 170 meters away. At 8 seconds, which car is furthest away from Tina? At 8 seconds, the blue car is further away. It's at 260, the red car is at 230. And how far ahead of the other car is it? So that's not how far away is it from Tina. How far ahead of the other car is it? So if this car is 230 from her and the other car is 260, this car is further away and it's 30 meters past the other car. Okay? On the diagram in the next stage, draw graphs of the distance between them. Okay, I'm not going to do that one because I can't draw graphs right now. I'm hoping in the next week or so, or the next few days, to be able to start doing stuff on GeoGebra, recording that on my Chromebook and sharing it that way with you. But at the moment, fancy complex graphs I can't do. Okay? But you should still be able to do them yourselves. You have done loads, so there's not really an excuse. Okay? So write down a formula to represent the distance between the red car and Tina for any given time. So the red car started at 70. Okay? Didn't it? I think it was 70. Yeah, it started at 70. Then 90, then 110. Okay, so this is at 1 second, 2 seconds, 3 seconds. So it's going up by 20. So I'm going to give my formula. I'm going to say S for seconds. Okay, the number of seconds times 20. Well, 1 times 20 is 20. But at 1 second, it's 70 away. At 2 times 20, that's 40, but it's 90 away. So I need to add 50 each time. So that is your general formula. This is a linear patterns bit that was thrown in, and you will see this in these questions. You could have a speed, distance, time question that throws in a linear pattern. The stuff that we were doing just before the schools were closed. Remember with our boxes and stuff. So you should have been able to answer this, folks. And then they want the same thing for the blue car. Okay, well the blue car was 20, I believe. Yeah. So, but it was going up in 30. So this time here is, so it's 1 second it's 20, at 2 seconds it's 50, at 3 seconds it's 80. So it's going up by 30 each time. So it's going to be 30 times s per seconds. But 30 times 1 is 20. And we have 30. 30 times 2 is 60. So in this case, it's 10 bigger. So our general formula for the blue car is 30s minus 10. Use your formula to verify the answers that you were given for the other one. Okay, so that means we just sub in, okay? So we said at 5 seconds they were the same distance apart, and they want us to verify that. So 20 times 5 plus 50. Okay? Was it 5 seconds? Damn, I can't remember now. I've rubbed it out. I thought it was 5 seconds. Do you know, I'll have to come back to this one. I actually can't remember which time it was, and I've rubbed that one out, guys. But look, it's in the solutions that I gave you, so don't be worrying about it, okay? All you do is sub in the seconds for each one, and you'll get the same answer. So we're nearly there, folks. Question 9, also labelled question 3. Mary is on page 12 of this document. Mary is planning to fly to London. The table shows the flights leaving Dublin and arriving in London, blah, 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 blah. She needs to arrive in Heathrow by 10:30. So, what's the latest she can leave? The closest arrival time in London Heathrow is 10:15. The next one after that is at 11:10. So that means she can get any one of the first 3 flights. Okay? She can leave Dublin at 6:40, arrive at 8:05, leave Dublin at 7:30, arrive at 9:05, leave Dublin at 8:50, arrive at 10:15. Any of those 3 will work for her, and she'll be fine. Okay? Find the time for her flight in hours and minutes. Well, if she leaves at 6:40, let's get that up to 7. That's 20 minutes. She would land at 8:05. So that's 1 hour and 5. So the total, 1 hour 25 minutes. Okay? Mary would like to arrive in Dublin Airport 75 minutes before that flight leaves. So the latest flight she can get is the 8:51. And she wants to arrive 75 minutes before that. And let's think about that. 75 minutes is the same as 1 hour and 15 minutes, okay? So if she has to be there, if the plane leaves at 8:50 and she wants to be there an hour and 15 minutes or 75 minutes before it, well, minus 1 is going to give us 7 hours and 50. And then minus our 15 minutes, 7 hours 35. So 35 past 7. Now we have another bit. She checks in one bag. The fare summary for her journey is given as below. Find how much taxes and charges amounts to. Okay? So, her ticket, $74.90. Taxes, we don't know. Baggage, €25. And her total, 133.88. Well, folks, this is just basic adding and taking away. There's no excuse if you don't get this, alright? I'm serious. So, 74.99 plus 25. 99.99. 133.88 minus 99.99. And like, you can do this on your calculators. 33.89, and that's how much the baggage cost. And that's it. Really, really simple question. Now, The distance from Dublin, yet again, distance, what do? You draw this triangle. As soon as you see that. Distance from Dublin to London, 464 kilometers. Okay? Find the average speed of the flight, of the plane during the flight. Now we said that this flight was going to take her an hour and 25 minutes. Okay? So what I would do is I change that into minutes just right now, okay? 1 hour and 25 minutes is 85 minutes, okay? You'll see why I'm doing this now, to make things a bit easier for us. 640 divided by 85. Okay, now, so that's going to give me the time in kilometers per minute. And then if I multiply that whole thing by 60, it will give me the speed in kilometers per hour, 327.5 kilometers per hour, which is pretty fast, but it's a plane. Okay? And that is the last question. So I hope this was okay. I hope this setup worked for you. I'll be uploading this video now today, Tuesday, and I'm going to try and have another video uploaded for you soon. Bye.